Alright, today's lab is making soap. Now, soap that we're going to make in the lab today, we're going to use vegetable oil. And here is a structure of a vegetable oil. Alright, and so it is a triglyceride. And notice that it is a vegetable oil, and so we have double bonds, not just any type of double bonds. Notice the hydrogens are on the same side of that double bond, one on this and then here. So that is a cis double bond. And so your oils are unsaturated fatty acids. All right, so we have three fatty acids that react with our glycerin to make our oil. All right, so we have purchased oil. We have also purchased lye. Lye is sodium hydroxide. It's also drain cleaner. So we're going to mix our oil and our lye in a blender with some water, and we're going to form soap. And soap is simply a deprotonated fatty acid. And so there is the negative oxygen. There should be a positive sodium with that as well to neutral. It is a neutral compound to balance the reaction. All right, and so we get three of our deprotonated fatty acids, and that is our soap. And when we make soap, it's called saponification. And we also get glycerin. All right, and so you get your glycerin as well as you get your soap. All right, so back to the structure of the oil. The oil contains at least one unsaturated fatty acid with at least one cis double bond. If it only had one cis double bond, it is a monounsaturated fat. In the example that I have here, there are three double bonds, and so this is a polyunsaturated oil. All right, so this is a oil because it has the cis double bond. So it's an oil when it's a liquid at room temperature. All right. And they come from vegetables, so they're called vegetable oils. All right, if there is a trans carbon-carbon double bond where the hydrogens are on opposite sides of the carbon-carbon double bond, then you have a trans fat. And trans fats have been pretty much eliminated from all foods as they are not healthy. All right, and so I already went through that. This oil has three cis double bonds, and that is then considered a polyunsaturated oil. All right, and so the more double bonds you have, the lower the melting point is going to go, and these oils are all liquids at room temperature. If you have no carbon-carbon double bonds, then you're going to have a higher melting point, and then you're going to be a solid at room temperature. And when you have all saturated fatty acids, then you have an animal fat, which is then a solid at room temperature. All right, so let's convert our oil and our drain cleaner into soap. All right, so here I have taken my household lye, 100% lye drain cleaner, and I measured out 70 grams, and it's been sitting here a little bit and it's been absorbing some water, but we have 70 grams of lye, which is sodium hydroxide. And in this beaker I have 175 mils of water, and my temperature I'm starting at is about 25.8 degrees Celsius. And then over here I have my vegetable oil. I have 350 mils of my vegetable oil. And here we have our lab blender, nice antique lab blender. All right, and so we're going to blend it up. We're going to pour it into our Pringles can. Then we're going to let that set for 2 weeks. All right, so we're not going to show the end product. Here is some that we had from the past. All right, and so here is what it will end up with. This is going to be your lye soap. All right, so you let it sit for 2 weeks in the Pringles can, and then you can use a knife and cut nice pieces of soap off. And this is again a hand soap. This is a lye soap. All right, so let's do the experiment. All right, so there's centered on the blender. All right, so we have our directions. In a 250 ml beaker, we want to mix 175 mils of water and 70 grams of lye. All right, and so this is sodium hydroxide, and it can cause a lot of damage. It is a very dangerous compound. All right, so I have the thermometer because this is very exothermic. All right, and so I'm going to dissolve my sodium hydroxide with my water. All right, and so, and this is an alcohol thermometer, not a mercury thermometer. All right, and so it used to be you could never use your thermometer as a stirring rod, probably still a pretty good rule of thumb. But that was mainly because it would break and then mercury's everywhere. Now that they are made from alcohol, if they break, it doesn't matter, it's just alcohol. All right, they do cost money to replace them versus a stirring rod, which doesn't usually break and they are dirt cheap. The temperature is at 95.8. All right, so it went up 70 degrees. Very hot. So you can see the steam forming on here. This is a very exothermic process, and so if you have ever used your drain cleaner to clean a drain, it is very dangerous. It can boil out the water and it shoots up in your face and you have boiling sodium hydroxide in your face. All right, so when you're doing your drain cleaning, you should also wear eye protection. All right, and make sure you follow the directions carefully. All right, so we have mixed that. We're going to add vegetable oil to the blender. All right, so I have the vegetable oil, and it says you can add a dash of peppermint extract. That is optional. I'm not going to add that. Then I'm going to add the contents of the beaker, and then I'm going to blend it for 1.5 minutes, pour it into my Pringles can, and we have made soap. All right, so let's see what this looks like. Put in my oil. I'm going to put in my lye solution. I'm not going to add my peppermint extract. I'm going to put on the lid and I'm going to blend it for 1.5 minutes. All right, here we go. So you have to be very careful as you use these antique blenders. We had some that shot out. Alright, so then we remove it carefully. It is soap, but right now it is a highly concentrated sodium hydroxide soap. Alright, and we may need to get pretty thick many times it's more liquidy at this point. All right, so here it's more of already a soap. And pour that into your Pringles can. Let that sit for 2 weeks. And then you cut it into bars of soap. And it is very good for getting oil off your hands. If your hands, you know, a mechanic that can't get his hands clean, you can let him borrow some of this lye soap, and that should take care of it. Anyone that has sensitive skin should not be using lye soap. Alright, I'm going to have to get a different tool to put the rest of this in, but you get the idea. That is your soap, and the temperature is still very, very hot, as this is an exothermic reaction. And so that is how you can make soap. You can make soap at your house with vegetable oil and drain cleaner.